Hi folks, welcome to this quick look through L'Hopital's rule for rational expressions. So the basic idea is if we have a limit that gives us 0 over 0 or infinity over infinity, then we can try just taking the limit of the derivative of the top over the derivative of the bottom. These forms 0 over 0 or infinity over infinity are called indeterminate forms. There are actually 7 different indeterminate forms, but we're going to only deal with these 2 in this video. When we use L'Hopital's rule, it's important to establish that we really do have one of these indeterminate forms before we try and use the trick. Okay, first up we have a cubic over a linear. When I sub in, I'm going to get 0 on top and 0 on the bottom. So I really do have one of these indeterminate forms. That means that this is a good candidate for L'Hopital's rule. My next step is to find the derivative of the top and the derivative of the bottom. So there's the derivative of the top. Here's the derivative of the bottom. It's just 1. And now we can take the limit of those blue and red expressions. This limit is easier to evaluate. I can now put in 1, and I'll get 3 times 1 squared is 3, plus 4 times 1 is 4, minus 8, and that's all over 1, for a final answer of negative 1. Which is the correct answer to the original limit that was asked. Now, L'Hopital's rule is not the only way to answer this question, but it is a pretty slick way. Let's try it with this one. If I put in 0, I'd get the sine of 0 over the sine of 0, and the sine of 0 is 0, so I'd get 0 over 0, which is an indeterminate form. Great, that means that this is one that we can use L'Hopital's rule on. Let's find the derivative of the top. So it would be the cosine of 5x times 5 from the chain rule. The derivative of sine 3x is going to be cos 3x times 3 from the chain rule. And now we can write with the derivative of the red and the blue. Maybe this doesn't look a whole lot better, but let's try subbing in now. So we'd get 5 times the cosine of 5 times 0, which is just 0, over 3 cos 0. And the cosine of 0 is 1, so that gives us 5 times 1 over 3 times 1, or 5/3, which is the correct answer to the original question. Here's one last one. We've got the limit as x goes to infinity of x squared over e to the x. If I sub in infinity, I'll get infinity squared over e to the infinity, or infinity over infinity. That's an indeterminate form, so it's okay for us to use L'Hopital's rule. Derivative of the top is 2x, derivative of the bottom is e to the x. Let's rewrite. So we found this is equivalent to the lim as x goes to infinity of 2x over e to the x. Let's try subbing in now. And what we'll find is we get 2 times infinity over e to the infinity. Oh no, we've got infinity over infinity again. So we haven't got an answer yet, but it means that it's still in indeterminate form, which means we can apply L'Hopital's rule again until we get a result. So the derivative of the top now would be 2. The derivative of the bottom is going to be e to the x. Let's find the new limit. So now we've got the limit as x goes to infinity of 2 over e to the x. When I think about subbing in infinity, I'd get 2 over e to the infinity. That's 2 over very large, or essentially 0 when we're done. So we get a result in the end. Maybe you could tell that result from the very first step, but we have a slick way of getting there now. L'Hopital's rule can help you out a lot with difficult limits, or just save you the pain of trying to find other analytic techniques. I hope that you found this useful. There are a ton of other videos out there that can give you a little more insight on how to use this in greater depth. But if you do use L'Hopital's rule, make sure that you are satisfying the condition that it really is in indeterminate form before you use the rule, which for us, for now, is infinity over infinity, or 0 over 0.